Topic: Cylinder and cone. Learning area: mensuration. Hello students, look at these pictures. Pillars, drum, tent, fire extinguisher, dosa. What shape are they? Yes, pillar, drum and fire extinguisher are of cylindrical shape. Tent and dosa are of conical shape. At the end of this lesson, the students will be able to know surface area and volume of right circular cylinder, know surface area and volume of hollow cylinder, know surface area and volume of right circular cone, know about hollow cone, know the volume of frustum of a cone. Right circular cylinder. Consider a rectangle OO-AB which revolves about its side OO- and completes one full round to arrive at its initial position. The revolution generates a right circular cylinder as shown in the figure. A right circular cylinder is a solid generated by the revolution of a rectangle about one of its sides. A right circular cylinder has two plane ends. Each plane end is circular in shape and the two plane ends are parallel to each other. Each of these two ends is called the base of the cylinder. The line segment joining the centers of the two circular ends, OO-, is called the axis of the cylinder. The axis is always perpendicular to the bases of a right circular cylinder. The line that joins the centers of these two base circles is called the axis of the cylinder, and the length of the axis of the cylinder is called its height, and the radius of the circular bases is known as its radius. The curved surface joining the two bases of a right circular cylinder is called its lateral surface. In the figure, OO- is the axis of the cylinder, O-A is equal to OB is its radius and OO- is the height. For a right circular cylinder of radius r and height h, we have base area of the cylinder is equal to pi r squared square units. Volume is equal to base area times height is equal to pi r squared times h, which is equal to pi r squared h cubic units. Curved surface area is equal to circumference of the base times height. It is also called as lateral surface area. It is equal to 2 pi r h square units. Total surface area is equal to curved surface area plus 2 times base areas of the cylinder. It is equal to 2 pi r h plus 2 pi r squared. Taking 2 pi r as common, we get 2 pi r times h plus r. Thus, the total surface area is equal to 2 pi r times h plus r square units. Let us do a few problems on surface area and volume of cylinder. Example 1. The diameter of a cylinder is 28 centimeters and its height is 20 centimeters. Find the curved surface area, total surface area and volume. Solution. Given that diameter is equal to 28 centimeters and height h is equal to 20 centimeters. Radius r is equal to 28 by 2 is equal to 14 centimeters. We know that curved surface area is equal to 2 pi r h square units. Substituting the values of r and h, we get 2 times 22 by 7 times 14 times 20. Multiplying, we get 44 times 40, which is equal to 1760 centimeters squared. Base area is equal to pi r squared, which is equal to 22 by 7 times 14 times 14 is equal to 44 times 14. That is equal to 616 centimeters squared. Total surface area is equal to sum of curved surface area plus 2 base area. It is equal to 1760 plus 1232, which is equal to 2992 centimeters squared. Now let's find the volume of the cylinder. It is equal to pi r squared h. Substituting, we get 22 by 7 times 14 times 14 times 20. Simplifying, we get 44 times 280, which is equal to 12,320 cubic centimeters. Example 2. The circumference of the base of a cylinder is 25.45 meters and its height is 15 meters. Find the total surface area. Solution. Given that circumference of the base is equal to 25.45 meters, height is equal to 15 meters, we need to find the total surface area of the cylinder. We know that curved surface area is equal to circumference of the base times height. Substituting the given values, we get 25.45 times 15, which is equal to 381.75 meters squared. Using circumference of the base, we can find radius of the cylinder. That is, 2 pi r is equal to 25.45 meters. From this, we arrive at r is equal to 25.45 times 7 whole divided by 2 times 22. It is equal to 178.15 by 44, which is equal to 4.05 meters. Now, base area is equal to pi r squared. Substituting, we get 22 by 7 times 4.05 times 4.05 is equal to 51.55 meters squared. Total surface area is equal to 381.75 plus 2 times 51.55. It is equal to 381.75 plus 103.1, which is equal to 484.85 meters squared. Example, a cylinder of maximum volume is cut out from a solid metal cuboid of length 20 centimeters and cross-section a square side 14 centimeters. Find the volume of the metal wasted. Solution. A solid metal cuboid of length 20 centimeters and cross-section a square side 14 centimeters is shown. We can get a cylinder of maximum volume by cutting a circular portion along the side as shown. Thus, we get a cylinder of height 20 centimeters and diameter 14 centimeters. We know that volume of a cuboid is equal to length times breadth times height. Here, length is 20 centimeters and breadth and height is each 14 centimeters. Substituting, we get 3,920 centimeter cube. Here, radius of the cylinder r is equal to 14 by 2 is equal to 7 centimeters. Volume of cylinder is equal to pi r squared h. Substituting the values of r and h, we get 22 by 7 times 7 squared times 20. Simplifying, we get 22 times 7 times 20, which is equal to 3080 centimeter cube. We can find the volume of metal wasted by subtracting volume of the cylinder from volume of the cuboid. It is equal to 3920 minus 3080, which is equal to 840. Thus, the volume of wasted metal is equal to 840 centimeter cube. The figure shown is a solid cylinder. When a big circular hole is drilled on the center of its base, that is, the center of the cylinder hole and the center of the circular face of the cylinder should coincide. Then we get a hollow cylinder. Definition: a solid bounded by two coaxial cylinders of the same height and different radii is called a hollow cylinder. Let capital R is the external radius and small r is the internal radius of the hollow cylinder. H is the height. Area of each end is equal to area of outer circle minus area of inner circle. That is pi capital R squared minus pi small r squared, which is equal to pi times capital R squared minus small r squared. Curved surface area is equal to external surface area plus internal surface area. It is equal to 2 pi times capital R times h plus 2 pi times small r times h, which is equal to 2 pi h times capital R plus small r square units. Total surface area is equal to curved surface area plus 2 times area of base rings. It is equal to 2 pi h times capital R plus small r plus 2 pi times capital R squared minus small r squared. Simplifying, we get 2 pi times capital R plus small r times capital R minus small r plus h square unit. Volume of the hollow cylinder is equal to exterior volume minus interior volume of the cylinder. It is equal to pi capital R squared h minus pi small r squared h. Taking pi h as common, we get pi times h times capital R squared minus small r squared. It is equal to pi times h times capital R plus small r times capital R minus small r cubic centimeter. Example: the inner and outer radii of a hollow cylinder are 8 centimeters and 10 centimeters respectively. If its outer surface area is 440 square centimeters, find its inner surface area. Solution: given that inner radius is equal to 8 centimeters, outer radius is equal to 10 centimeters, and outer surface area is equal to 440 square centimeters, we know that outer surface area is equal to 2 pi times capital R times h, that is equal to 440 square centimeter. Substituting the value of R in the above formula, we can find height of the hollow cylinder. That is 2 times 22 by 7 times 10 times h is equal to 440. Cross multiplying, we get h is equal to 440 times 7 the whole divided by 2 times 22 times 10. Cancel out the common terms and we can get 7 centimeter as height. Thus, the height of the hollow cylinder is equal to 7 centimeter. We know that inner surface area of the hollow cylinder is equal to 2 pi times small r times h. Substituting the value of small r and h, we get 2 times 22 by 7 times 8 times 7. Cancel outing 7, we get 44 times 8. It is equal to 352 centimeters squared. Thus, the inner surface area of the hollow cylinder is equal to 352 centimeters squared. Example 2. A hollow cylindrical iron pipe is 40 centimeters long. Its outer and inner diameters are 8 centimeters and 5 centimeters respectively. Find the volume of the material and the weight of the pipe if 1 cubic centimeter of iron weighs 7 grams. Solution: given that outer diameter is equal to 8 centimeters, inner diameter is equal to 5 centimeters, and height of the pipe is equal to 40 centimeters. Outer radius is equal to 8 by 2 is equal to 4 centimeters. Inner radius is equal to 5 by 2 is equal to 2.5 centimeters. We know that volume of the hollow cylinder is equal to pi times h times r plus r times r minus r cubic units. Substituting the values and simplifying further, we get 22 by 7 times 40 times 6.5 times 1.5, which is equal to 1225.7 cubic centimeter. Given that weight of the pipe for 1 cubic centimeter is 7 grams. Therefore, weight of the hollow cylindrical iron pipe is equal to 1225.7 times 7, which is equal to 8580 grams. Since 1000 grams is equal to 1 kilogram, 8580 grams is equal to 8.58 kilograms. Thus, the weight of the pipe is equal to 8.58 kilograms. Consider VO is a fixed line. V is the fixed point and VA is the revolving line which makes a constant angle theta with VO. If the segment VA revolves about VO, it generates a hollow cone with open base. The fixed point V is called the vertex of the cone. The fixed vertical line is known as its axis, and the revolving line VA is called generator of the cone. If the segments VA and OA of the right triangle OAV revolve about VO, we get a hollow cone with closed circular base with center O and radius OA. If the plane lamina VOA revolves about VO, we obtain a solid cone. We can define cone as a right circular cone is a solid generated by revolving a line segment which passes through a fixed point and which makes a constant angle with a fixed vertical line. Height of the cone. The length of the segment VO is called the height of the cone and is generally denoted by H. Slant height of the cone. The length of the segment VA is called the slant height of the cone and is generally denoted by L. Radius of the cone. The radius OA of the base circle is called the radius of the cone and is generally denoted by R. In the right angle triangle OAV, by Pythagoras theorem, VA squared is equal to VO squared plus OA squared. That is, L squared is equal to H squared plus R squared. Slant height L is equal to square root of H squared plus R squared. Volume of a cone is equal to 1 by 3 times base area times height. That is equal to 1 by 3 times pi r squared times H. Volume of a cone is equal to 1 by 3 pi r squared H cubic units. If we open a hollow cone, we get triangle shape of height L, which is slant height of the cone, and base 2 pi r, which is circumference of the base of the cone. What is the area of a triangle? Yes, area of a triangle is 1 by 2 times base times height. Here, applying the formula for the surface area of a cone, we get 1 by 2 times 2 pi r times L. Cancel out in 2, we get pi times r times L. Curved surface area of a cone is equal to pi rl square unit. Total surface area of cone is equal to curved surface area plus base area. We know that base area is equal to pi r squared. So, total surface area is equal to pi rl plus pi r squared. Taking pi r as common, we get pi r times L plus r. Thus, total surface area of a cone is equal to pi r times L plus r. Example 1. What are the lateral surface area and the total surface area of a cone whose slant height is 10 cm and base diameter is 14 cm? Solution. Given that slant height L is equal to 10 cm and diameter is equal to 14 cm, Radius of the base of cone R is equal to 14 divided by 2, which is equal to 7 centimeters. We know that lateral surface area of a cone is equal to pi RL square units. Substituting the values of R and L, we get 220. Thus, lateral surface area of the cone is equal to 220 centimeters squared. Total surface area of a cone is equal to pi r times L plus r square units. Substituting the values of r and L and simplifying, we get 374. Thus, total surface area of the cone is equal to 374 centimeters squared. Example 2. If the slant height and diameter of a conical tomb are 25 meters and 14 meters respectively, find the volume of the conical tomb. Solution. Given that diameter of the base of conical tomb is equal to 14 meters, radius is equal to 14 by 2, which is equal to 7 meters. Slant height is equal to 25 meters. We know that L squared is equal to h squared plus r squared. We need to find height of the conical tomb. So, h squared is equal to L squared minus r squared. H is equal to square root of L squared minus r squared. Substituting the values of L and r and simplifying, we get 24. That is, height is equal to 24 meters. We know that volume of cone is equal to 1 by 3 pi r squared h cubic units. Substituting the values and simplifying, we get 22 times 7 times 8, which is equal to 1232 meter cube. Consider a sheet of paper in the form of a sector of a circle. Let the sector be AOB of the circle. Now, fold it by bringing OA and OB together, then we get a hollow cone. Radius of the sector becomes the slant height of the cone. Length of the arc AB becomes the circumference of the base of the cone. Length of the arc AB is equal to theta by 360 into 2 pi r. Theta is the angle of the sector. R is the radius of the sector, and let R be radius of cone. Since length of the arc is equal to circumference of the base of the cone, 2 pi r is equal to theta by 360 into 2 pi r. Simplifying, we get small r is equal to theta by 360 into capital R, where radius of the sector is equal to slant height L. So, radius of a cone is equal to theta by 360 into L. Example 1. A sector containing an angle of 90 degrees is cut from a circle of radius 20 centimeters and folded into a cone. Find the curved surface area of the cone. Solution. Given that the angle of the sector theta is equal to 90 degrees, radius of the sector R is equal to 20 centimeters. We know that the slant height is equal to the radius of the sector. So, slant height L is equal to 20 centimeters. Radius of a cone R is equal to theta by 360 into L. Substituting the values of theta and L and simplifying, we get 5. That is, radius of cone R is equal to 5 centimeters. Curved surface area of cone is equal to pi RL square units. Substituting the values of R and L, we get 100 pi. Thus, curved surface area of the given cone is equal to 100 pi centimeter squared. Example 2. A conical tent of base radius 5 meters and height 12 meters is opened out into a sector. Find the central angle of the sector. Solution. Given that radius of cone is equal to 5 meters and height is equal to 12 meters. Slant height L is equal to square root of r squared plus h squared. Substituting and simplifying, we get slant height is equal to 13 meters. We know that radius of the sector is slant height. So, radius of the sector is equal to 13 meters. We know that radius of a cone, r, is equal to theta by 360 times radius of the sector. Substituting the values, we get 5 is equal to theta by 360 times 13. Theta is equal to 360 times 5 whole divided by 13, which is equal to 138.46 degrees. Thus, central angle of the sector is equal to 138.46 degrees. Frustum of a cone. Have you seen buckets or bowls? What shape are they? They are shape of frustum of a cone. When a plane is cutting a right circular cone parallel to its base, we can get a frustum of a cone. Definition: a solid cut by cutting a right circular cone by a plane parallel to the base is known as frustum of a cone. Now let us find volume of frustum of a cone. Consider a cone of radius r and a plane cuts the cone parallel to its base such that height of the cone is separated as h and x. Now, volume of the frustum V is equal to 1 by 3 pi capital R squared times x plus h minus 1 by 3 pi small r squared x cube units. In the figure, triangle BFE is congruent to triangle CGE. Capital R by small r is equal to h plus x whole divided by x. Rearranging, we get x is equal to RH divided by capital R minus small r. We know the volume of frustum. From that, taking x as common, we get this step. Replacing x by RH divided by capital R minus small r, we get this step. Further simplifying, we get 1 by 3 pi h into capital R squared plus capital R times small r plus small r squared. Thus, the volume of frustum of a cone V is equal to 1 by 3 pi h into capital R squared plus capital R times small r plus small r squared cubic units. Example 1. Find the volume of frustum-shaped stone as shown. Take pi is equal to 22 by 7. Solution. Given that radius of lower base is equal to 30 centimeters, radius of upper base is 20 centimeters and height is 14 centimeters. We know that volume of frustum of cone is equal to 1 by 3 pi h into capital R squared plus capital R times small r plus small r squared cubic units. Substitute the values of capital R, small r and h. Thus, volume of the stone is equal to Example 2. The diameter of the bottom of a bucket is 14.4 centimeters and that of the top is 43.2 centimeters. Its depth is 28 centimeters. Find the capacity of the bucket. Take pi is equal to 22 by 7. Solution. Given that diameter of the bottom of the bucket is equal to 14.4 centimeters. Radius of the bottom of the bucket R is equal to 7.2 centimeters. Diameter of the top of the bucket is equal to 43.2 centimeters. Radius of the top of the bucket R is equal to 21.6 centimeters. Height of the bucket H is equal to 28 centimeters. Bucket looks like a frustum of a cone. So, using volume of the frustum of a cone, we can find the capacity of the bucket. Substituting the values of capital R, small r and height, we get the step as shown. Simplifying, we get 1 by 3 times 22 times 4 times 600 and 73.92. Further simplifying, we get 90,768.32 centimeters cubed. Thus, the capacity of the bucket is 19,768.32 centimeters cubed.